Hey guys, it's Mr. Mock, and I just wanted to go over for algebra the zero product property and then solving by factoring when it comes to quadratics, okay? So what we see here are two binomials that equal zero. So what I'd like you to consider is if we were to distribute this out, it would give us a quadratic. It would give us an x squared. It would give us 2x times x. It would give us a 2x squared plus 6x minus x minus 3. So it would be 2x squared plus 5x minus 3 equals 0, right? So this has been factored into these two binomials. So when it says to use the zero product property to solve, remember when we're talking about a quadratic and we're solving, we're looking for two answers where the parabola is going to cross the x-axis in two different places. Maybe one answer where the vertex is on the x-axis, or no answers because none of the parabola is going to cross the x-axis at all. In this particular situation, we've factored it out, so we have these two binomials. So when it says to use the zero product property, you take each of the binomials, right? And you set them each individually equal to 0, right? Because whatever x is here, in this case, when x is -3, you're going to get a 0 for this binomial. So it doesn't really matter what's here. Anything times 0 is going to give you 0. So what we're doing is trying to find what does x have to be for each of these binomials in order for us to have 0. So in this case, your answers are x equals 1/2 and x equals -3. Those are where you have, so -3, 0 would be where the parabola crosses, and 1/2, 0 will be where the parabola crosses for this particular equation. So then the same would be true for this one. You do 2x plus 3 equals 0. You do 3x minus 1 equals 0. You subtract 3 on both sides. X will eventually equal -3/2. You add 1. 3x equals 1. So that eventually x equals 1/3 when you divide 3 on both sides, right? So you know now x is -3/2, x is 1/3, and those are the locations where the parabola is going to hit. So there's two solutions, right? And this, and, all right? Because it's both solutions, all right? So then when it comes to factoring, you're looking down at this problem, and it says to solve. Well, we can go ahead and create our two binomials if this is factorable. So can we look at this and factor it pretty quickly? We have x, and now 64, that's a perfect square, isn't it? So isn't this one, check this out, right? Because it's a perfect square, and then the 8s add up to 16. So really you have x plus 8 squared. So really you just have to solve it once, because what we're going to find is because x has got to just be one solution here, x is going to be equal to -8. That means this parabola connects to the x-axis at one place, right at the vertex. All right? So you factor and then solve each individual binomial to get where the quadratic crosses the x-axis. All right, guys, I hope that helped. See you later.